The human brain, made up of 86 billion neurons and trillions of connections, is considered the most complex structure in the universe. Inside, there is an order that brings together time, space, sensations, and information. However, when asked about the capacity of this astonishing organ, providing a clear answer becomes harder than we think. Can it really be measured like a computer's hard drive? In this era defined by terabytes, how much data can the human mind store? Scientists have been seeking the answer to this question for years. To give an approximate figure, it is estimated that the average human brain can store up to 2.5 petabytes of information. That means about 2,500,000 gigabytes. But this is just the beginning. Unlike hard drives, the brain compresses data, relates it with context, and combines it with emotions. Thus, the mystery is not only in how much it stores, but also in how it stores it. The brain's information storage system, roughly speaking, has the functions of a RAM and a hard drive. Short-term memory holds information for a few seconds to a few minutes. Phone numbers, a newly introduced name. If the information is deemed important, it moves to long-term memory. This is where synaptic connections come into play. As the connections between neurons are strengthened, information becomes permanent. That's why repeating something helps to remember it longer. However, the capacity of the brain is not limited to mere storage. Creating meaningful links and relationships between different concepts helps organize information much more effectively. How much information does a petabyte contain? To compare, think of the following. 2.5 petabytes equals sign. About 3 million hours of video equals sign 300 years of uninterrupted movies. Or 2.5 million GB equals sign about 4.5 billion pages of books. Or the sum of all visual, auditory, and linguistic experiences a person can have throughout a lifetime. But here's an important distinction. The brain not only stores the information it collects, but also processes it, analyzes it, makes predictions, and restructures it. This is the key feature that sets it apart from an ordinary digital device. A common misconception is that humans use only 10% of their brains. This myth has been scientifically debunked. Thanks to imaging technologies, we now know that during different tasks, almost the whole brain becomes active. But one fact remains. We do not use all of our memory because we don't need to. The brain ensures energy efficiency by eliminating unnecessary information. Memory is less an archive and more like an active editor. It keeps what matters, erases what's unnecessary, and rewrites some information. This dynamic nature increases both the brain's capacity and its functionality. Although forgetting is often seen as a weakness, it is actually vital to the brain's efficiency. If it were possible to remember everything, decision-making could be paralyzed. That's why the brain applies filters to information like emotional value, frequency of repetition, and importance. In this context, the brain's memory capacity is not fixed but highly flexible. Depending on how we use it, it can expand or contract. Just like muscles, it strengthens when trained. Habits that reinforce memory, reading, learning, problem-solving, increase the brain's information processing capacity. Today, information is stored in mobile phones, cloud systems, and AI-supported databases. These digital memories are seen not as a threat to the brain's natural capacity, but as a support. Humans are still the most effective information processors thanks to emotional context and intuitive thinking. However, the brain has had to adapt to a digitalized world. As access to information has become easier, the need to memorize has diminished. But if this means using our brain capacity less, we may be stunting a large part of our potential. Is it possible to exceed the limits of brain capacity? Neurotechnology is in pursuit of this question. Brain-computer interfaces, BCI, can convert brain signals into digital data. In the future, there is talk of an era when people can export their memories or directly download information. Although it sounds like science fiction, the foundations of these technologies have already been laid. However, its ethical, psychological, and neurobiological implications require deep discussions. Because enhancing brain capacity is not only a technical matter, but also one that could reshape the very definition of humanity. Measuring the capacity of the human brain only in gigabytes or terabytes is actually limiting it, because the human mind is not only a system that stores information, but one that gives it meaning, feeds it with emotions, and shapes it with imagination. Yes, a memory of 2.5 petabytes is mentioned, but this number is just a surface aspect of the brain's true potential. The real power lies in how the data is processed. the ability to make connections, and most importantly, the desire to learn. Don't forget to like, subscribe, and share your thoughts in the comments to continue exploring the mystery-filled universe of the brain.